All right, well, let's get going. So this is going to be 2.6, and 2.6 isn't in the textbook, and it's more or less just a continuation of 2.5. It's really just geometric proofs extended into more difficult examples, because in 2.5, all the examples we did are pretty similar, but before you get to more difficult proofs, which you will later in the year, you kind of need to dip your toes in the water, see how it is, and test it out. So it's normal when we do these for you to be a bit frustrated because they are difficult, but they're only difficult because they're totally new and you haven't seen them before. So the more you do it, you sort of get a flow for it and see the strategies that we can use. So you should have this worksheet here, 2.6, and we're going to go through the notes and let's get into it. All right, so our givens here are AC equals AB plus AB. So what they're really saying is that, what did I just do? That is not what I meant to do. Okay. Is my writer going to work? Okay. What they're really saying is that 2 of these equals the whole thing. Okay, so if I double it, so that would imply that BC is the same length, right, if we just have to double it. And that's exactly what they want us to conclude. AB equals BC. All right, now they do the proof for us, so we don't have to really make our own game plan. We can just follow theirs. So let's look at what they did and see if we can make sense of how they got what they got. All right, we got our givens. We got AB plus BC equals AC. Okay, so they're just saying that this half plus this half equals the whole thing. And we need to know what that name is because we're going to use this quite a bit. It's the segment addition postulate. And I am going to abbreviate this. That's not what I meant, right? Postulate with an O. I do abbreviate a lot of these things because we just write them so much, and if you're smart about how you abbreviate, you can still tell what it says. All right, let's look here. So going from here to here, it's not quite clear immediately what they're doing, but let's take a closer look here. So, okay, AB plus BC is still here, right? That stayed the same. That hasn't moved. However, this AC has become AB plus AB. And if we look back up here, that's our given, right? AC is the same as AB plus AB. So they just replace this, so we can call that substitution. All right, so we'll call that substitution. And we get to this last step here, so let's see what happens. And I always say start with the equation, see if you can figure out, and then if that doesn't make sense, go to the picture, okay? All right, AB plus AB becomes just AB, and then AB plus BC becomes just BC. So it looks like on each side, we're losing an AB. So that would, they're subtracting it, so that would be the subtraction property. All right, there you go. That's a proof, a more difficult proof, but not horrible, right? It's not a terribly long proof. So let's look at another one. Let's try to do one from scratch. All right, we're given that B is the midpoint of AC. So B is the midpoint. That means these are congruent. And we're also given that C is the midpoint of BD. So I'm just going to redraw this here. And they're saying that C is the midpoint of BD. So those are the two pieces of information we know. And they want us to say that AB equals CD. Okay, so in order to do this, let's first think about what we know here. All right, so if it's totally from scratch, make a game plan. Don't try to just dive into it. Usually that doesn't end very well. So our first fact here, we could say that AB equals BC. This fact here, we can say that BC equals CD. All right, well, let's look at what we're trying to get here. We're trying to get that AB equals CD. So what we're going to want to do is we're going to want to do a little substitution. Okay? So we know that AB and BC are the same thing. So we can replace this with AB and then just rewrite it. And we should be right where we want to be. They're the same, we can switch those out, and we should end up with AB equals CD, and we check, and that's exactly where we want to end up. So we have sort of an idea of what we want to do, right? This is really our or statements. We just have to make reasons for it and set up a proof. So why don't you try doing this one, see how it goes, and you can compare with what I have at the end here. All right? All right, so I'm going to do it now. Let's make our 2-column proof. Statement and reasons. All right, so I always start with my given. I'm a little bit lazy, and sometimes what I'll do is I'll just do quotes here. You can just look up here what's in the quotes, and then I'll just say given. All right, I don't really want to rewrite all that. It's already on the paper. All right, first thing I'm going to do is I'm going to say that these are equal. So AB equals BC, and that's going to be why? Why are those equal? Well, it's the definition of a midpoint. And then I'm going to state my second fact, this one right here, BC equals CD, and it's also going to be definition of midpoint. And we can put it all together by swapping these out. And we get AB equals CD, and that's going to be substitution. All right, there you go. There's your proof. Put a star by it. Fantastic. Okay, let's look at the next one where it gets a little bit more tricky and see what they did. Because they did this one for you. They usually have to fill in the blanks, which isn't always easy because they might think about it a different way than you do. Okay, so we know that PQ is congruent to RS, which is labeled here, and they want you to prove that PR equals QS. That's what they want you to show. All right, so we don't need to make a game plan because they already sort of laid it out for us. We just have to follow their reasoning when they have it like this. So this will be our given. See what they did here. We got PQ plus QR and RS plus QR. Let's compare these two lines, see what changed. All right, on the left side, it looks like they added a QR, right? Now it's PQ plus QR. And on the right side, they added a QR. So this is going to be the addition property. All right, segment addition postulate. So we're going to have to look and see what they're looking for here because it's kind of hard to tell what they're going for next. But let's look at the next line, what they did. They said that QS, so this right here, so I'm looking at line 4, QS is the same as RS plus QR. Okay, that is true. That is, it's just splitting these into two parts. Now, for 3, we can kind of make an educated guess that they're just going to use the other segment that we need at the end, right? So they already did QS. They're probably going to use PR and then do something with that. So we can make an educated guess, fill that in, and then at the end, if it's wrong, we can erase it. It's not, but that'll be your educated guess. So we're going to say that PQ plus QR equals PR. And that is because segment addition postulate. All right, we want to wrap this thing up. And they got here, okay? Which is kind of, it seems like kind of a big jump, but let's look at how they got there, okay? All right, so I'm going to break this down because I wish they would have done this in 2 steps to show what they did, but they did it all in one big step. All right, so right up here, we have PQ plus QR. What is that the same as? Well, we just said down here, it's PR. So what they're doing is they're taking this statement here, and they're going to replace each part. So they replace this first part with PR, okay? All right, they're going to take this statement again, and they're going to replace this second part, RS plus QR, with, well, let's look down here. What's that the same as? RS plus QR is the same as QS. So they're going to swap it out with QS. So they took this entire statement, they changed it twice, so really they did 2 substitutions, and they have this final statement, which is what we wanted to prove. So we would say substitution. All right, very good. Let's flip it over and look at the next one. Okay, so now they don't give us template. We have to come up with our own proof. And this one is a bit tricky. So I'll sort of walk you through the steps, and then we'll do it together. All right. so let's see what we're given. AB is congruent to FG. Good. And BF bisects AC and DG. It's hard to label here, but also these two halves are congruent. Okay, so these are midpoints, they're cutting them in half. Okay, it's kind of a lot of information to work with. And I'm going to prove that BC is congruent to DF. All right, okay. All right, well, let's list our information and see what we can do with that. Okay, the first thing we're going to list is, we're going to list that, well, we know our given. Okay, we'll write our given up here. So AB equals FG. Okay, we know that to start with. And then we know some midpoint facts. So we know that B is a midpoint. So we know that AB equals BC. And we also know that DF equals FG. Okay. So that's all we have to start with, but we can work from there. Okay, we want to get BC and DF. All right, so we have BC here and we have DF here, and I'll sort of walk you through the logic of what we're going to do. Okay. All right, so we're going to start by taking this statement here, and we're going to replace a part of it. Okay. So we know that AB is the same as what? It's the same as FG. So we're going to rewrite this, and we're going to say FG equals BC. Okay? Good. All right, and then from there, what we want to do is we want to replace FG again. Okay? So now we know that FG, so we can look again here. We know that FG is also the same as DF. So now we're going to change it again. So we're going to do 2 substitutions in a row. And that's because we have 3 equations here, so we have to take a couple steps to get there. Okay, so now we're going to rewrite this again. And this time, this is going to be DF. So now, we're closer. We have DF equals BC. Oh, hey, we're not closer. That's where we want to be, right? So we just have to do a couple switching around to make what we want. So that would be BC is congruent to DF. We switched it, we made it congruent, and we can deal with that later when we do a proof. Okay, so that's what we have to deal with, okay? So obviously this is a bit more tricky, takes a bit more time to mess around with it. This is kind of your framework, okay? This is our given, this is the stuff we have to state, and this is when we start substituting, okay? Well, so why don't you try that out, see how that goes, and this is going to be a tough one, like I said, first time around. So just get as far as you can and then just watch me as I go through it. All right, so let's do this thing. Let's slay this beast. Okay, so statements and reasons. We're going to start with our given. I'm just going to put quotes around this to save myself time. I'll say given. And then let's get into it. Okay, so first thing I want to state is that since it's bisecting it, I can say that. So AB equals BC. And that's definition of bisector. And then I'm going to state my other bisector, so DF. Remember, this is also being cut in half here. DF equals, what was I going to say? DF equals FG. And that's definition of bisector. Very good. All right, now I'm going to have to start substituting. Okay, so I've got these stated. I'm going to start replacing, so I'm going to substitute FG in for AB right here. So I'm going to say FG equals BC, and that's substitution. And then I need to substitute again, right? Because I don't want this just to be FG. I want this to be DF. So I'm going to say DF equals BC. Substitution again. And if I want the order to be correct, I would switch it and say BC equals DF. Well, I'm switching the order, so that'll be symmetric property. And then one final step, which I would consider optional, would be adding the congruent, because you've essentially said at this point. But we could say BC, segment BC is congruent to segment DF. And that is definition of congruent. All right, so kind of a beast, but there it is. Okay, that's about as difficult as it can get. Let's look at the next one. Next one is laid out for you. Just got to fill it in. Okay, so this is another one that would also be pretty tricky to do, but we have the steps for it. All right, so A, B, and CD bisect each other at point M. So that is congruent, and that is congruent. They bisect each other, so there's two pairs of congruent sides. They want us to prove that AB equals AM plus MD. Okay, all right. Well, let's just list our, actually, we can just follow their work here, and then it should start to make sense. All right, BM is congruent. Oh, they told us, I'm sorry, they told us something. They told us that BM is congruent to CM as part of our given. Okay. All right, so that is our given, and let's look at the next one. CM is congruent to DM. Okay. So let's look at our picture here. They're saying that CM is congruent to DM, and that's because there's a midpoint.
Come to the office, Jocelyn Key.
So we'd say definition of, it says they're being bisected, definition of bisector. Okay. Let's look at the next one, BM and DM. Okay. BM and DM can't get much from my picture. Let's look here. So it looks like they took this statement here and they rewrote it, but they replaced CM with BM. So they knew they were the same thing and they did substitution. Okay, let's look at this next one. They just dropped the congruences, so we can just call that definition of congruent. Okay, all right, we're on a roll. Let's do the next one. Segment addition postulates. All right, we have to kind of know what they're going for here. So let's look at where we end up here, right? Down here, they're talking about AB, and that's also what we're trying to prove up here. So we can kind of make an educated guess that they're going to end up splitting up this segment AB into its parts. So let's do that, and that is what they want, I'll tell you, but you'd want to see if it makes sense afterwards. So AB equals the two parts, AM plus MB. AM plus MB. Okay, let's compare. We go from here to here. What's changed? Well, if you look closely, that is the only thing that's changed. MB changed to DM, which we're told right here are equal. They just had write BM instead. Okay, so what is that? That's just substitution. If you haven't caught on by now, substitution is in almost every proof. I should probably spell it right though. So that's kind of like your go-to if you're not sure what they're doing. All right, very good. Last one. Let's finish this thing off. We got number 6. We're going to write a 2-column proof from this. All right, we got to make sense of it. We got to make our draft. I want you to try it out, see if you can do it. M is the midpoint of RT. Okay, so these are congruent. Good. So M is the midpoint of RT, and we want to prove that MT equals RS plus SM. All right, let's list what we could do here. All right, it's the midpoint, so we can say that RM equals MT. And how do we get to where we want to be? Now, we're going to have to use a couple facts here. So we want to get to Rn, right? And we're going to do RS plus SM. So at some point we're going to have to split RM into its two parts, RS and SM. So I'm just going to write it here and then we'll see what we can do with that. So RM also equals RS plus SM. Okay, let's take a look here and see, okay, I'm seeing something, maybe you're seeing it too. How could we get to our final result that we're trying to prove? Well, look at this. RM equals MT, and RM's right here. If we just swap those out and we make this an MT, well, let's look what we got. MT equals RS plus SM. Hey, look at that. That's what we're trying to prove. All right, try to make your proof, and then check and see if you get the same thing as me. All right, we're going to start off with our givens. You know me. I'm going to do quotes and say given. All right, what are we going to do? We're going to say that it's the midpoint, so those can be equal. So RM equals MT, definition of midpoint. And then we can say that we can split RM into its smaller parts. So RM also equals RS plus SM. And this would be, do you remember? It's segment addition postulate. And let's wrap it all up, put a bow on it. We want to replace this RM here with MT. So we're going to say MT equals RS plus SM, substitution. Substitution. There you go. Put a star by it, put a heart, put a smiley. You did it. Pat yourself on the back. Good job. Bye-bye.